Welcome to today's lesson on vectors. My name is Hampton. So to begin with, in this chapter of vectors, we're going to look at the definition of what a vector is. We're going to look at what a vector is and how you represent the vectors, the modulus or the magnitude of a vector. We'll look at the unit vectors. Then we'll look at addition and subtraction of vectors. We'll look at what parallel vectors are. And then apart from that, we'll also look at the dot and cross products of vectors. And then lastly, we'll look at the direction cosines of vectors. So this topic is very simple and straightforward, and it's very short. So I'll not even take much of the time explaining on vectors. So what are vectors? So according to physics, those physical quantities which have both magnitude and direction are called vector quantities. And the examples that we can give on these vectors are velocity, displacement, acceleration, force or pressure. All these are vectors. So let's now see how we represent vectors. So vectors can be represented when you see, for instance, a point on an x or y plane. You see a point on the x or y plane, for instance 3, 2. This can just be a point, but when you see something which looks like this, when you see 3, 2 in these types of brackets, then this is a vector. So this is a vector and then this is a point. So do not confuse the two. When you see something like this, this represents a vector and then this one represents a point. Okay, and then apart from that, you can also represent vectors in IJK notation. So this 3, 2 can also be written as 3i. This can also be written as 3i plus 2j. So if we had another number here, for instance 4, we can also include the third letter there, which is which is k, sorry. So meaning we're going to put 4k there. So this 3 here represents a point, or represent a position in the x-axis, and then this 2 represents a position in the y-axis, this one in the z-axis. So when you see a vector looking in this format, know to say it's a 3-dimension vectors, and then if it's only ending at j, then it's a 2-dimension vector. Okay, so let's look at this example, which says find the vectors u, v and w whose initial and terminal points are given. So like I said, what you've been given here are just points. So you need now to find a vector. So to find a vector, for instance, I'll just solve maybe 1 or 2 questions from here. So to find a vector u, so u is simply just equal to, when you're finding a vector, you always start with the head minus the tail. So a vector looks like this. So you start with a point on the head and then minus the point on the tail. So to find u, we're going to have u being equal to our initial point. Our initial point is this one, the terminal point is this one. So we say the terminal point minus the initial point, so meaning we're going to have 5, 6 being like that, and then minus 3, 2. So when you subtract these two, your u will now just be equal to, so this u is a vector. You can also give it direction on top like that. Okay, so this u now will be equal to, you change the types of brackets, then this will be 5 minus 3. So you subtract the corresponding terms. 5 minus that 3 there, you are going to get 2, 6 minus 2 you get a 4 like that. Okay, so this is what you are going to have as your vector. So we can also, I think, solve W. So I'll only solve 2 questions here because all these others can be solved in a similar manner. Yeah. So I'll also solve W. So W is also solved in the same way we've solved U. So this is going to be the terminal, which is 3, 3. So this one is a 3-dimension vector. Then minus -1, 2, 3, like that. So W will now be equal to, you subtract this and then you change the types of brackets. So 3 minus -1, you get 4, 3 minus 2, you get 1, 4 minus 3, you get another one, like that. So this is simply the solution for W there. This is the vector W that we've been taught to find. Okay, so let's quickly move on to the next step on vectors. We look at the modulus, or which is in other words called the magnitude of a vector. So a modulus, or the magnitude of a vector, is simply just is simply just found in the similar way you find the magnitude of a straight line on the x or y plane, or if not that, you can also find it in the same way you find the magnitude of a complex number. So if you've been given a vector, maybe for instance 3, 5, and then you've been told to find the magnitude of this. If this is, for instance, u, if your u is equal to that, meaning the magnitude of u will simply just be equal to 3 squared plus 5 squared, then the square root of that. In the same way you find the magnitude of complex numbers, that's the same way you find the magnitude of vectors. So it doesn't matter if it's in 3 dimensions. So if it's in 3 dimensions, you have maybe another number there, you are also going to include another number there, 1 squared. And of course, when you are squaring these, you have to make sure that you put them in brackets. It's important. So this will give you 9, that will give you 25, and then that will give you 1. So when you simplify this, that's the magnitude of a vector. Let's move on. So it's simple and straightforward. What is a unit vector? So a unit vector is simply just a vector whose magnitude is 1. So when you find the vector which has the magnitude of 1, so if for instance after finding the magnitude of vector u, you find that the magnitude is equal to 1, then that vector u is called the unit vector. Okay, so vector u will be called a unit vector because it has magnitude of 1. Let's proceed. So let's look at this example here, which says find the following. So the magnitude of u, so this one is straightforward. This is our u here. So if you take this as your u, meaning your v is going to be that. If you take this as your u, your v is going to be that. You take this as your u, your v is going to be that. So the magnitude of u, is simply just the square root. So we say the magnitude of u, so this is simply just the square root of that. So we say the square root of 1 squared plus -1 squared. So this will simply give you the square root of 2, which is just the square root of 2 as well. So from there you can find the magnitude of v, which is simple. You find it in the same way. You take this as your v, then you find this magnitude, you find it in the same way. Then to find the magnitude of u plus v, find the magnitude of u plus v. So when you're adding vectors, you just add them in the normal way. There's nothing like using the terminal minus initial. No, when you are adding vectors, you just add them directly. You just add the corresponding values. So for instance, if we're adding u plus v here, if we're adding u plus v, we're just going to add the corresponding value. So this 1 plus -1, you get a 0, then comma, -1 plus 2, you get a 1, then you close like that. So this is the solution. And then after adding them, we've been told to say we find its magnitude. Find the magnitude of u plus v. So the magnitude of u plus v is simply just the magnitude of this part. So the magnitude of this part is 0 squared plus 1 squared, and then the square root of that. So this will simply just give you 1. Yeah, so in other words, that's a unit vector. Remember what I said, the unit vector has a magnitude of 1. And then a unit vector is normally found by dividing two vectors. For instance, by dividing a vector, it's found by dividing a vector by its magnitude. For instance, when you divide u by its magnitude, you are going to have the unit vector of u. So if you find, for instance, you have this is u. So u can also be written in this format: I minus j. So I minus j. So this, you can write it in that format. So when you find the magnitude of this, remember we found the magnitude of u to be equal to the root of 2. So now to find the unit vector of u, so the unit vector of u is represented by u cap, which is equal to u is equal to I minus j. We're saying also minus j. So we're saying a unit vector is found by so we say if you're finding u cap, the unit vector of u is simply just u divided by the magnitude of u. So u divided by the magnitude of u is called the unit vector in the direction of u. And then the unit vector in the opposite direction of u, just simply add the negative in front. Okay, so we divide everything by the root of 2. We divide u by its magnitude. So when you divide this by its magnitude, we're going to find the unit vector to be 1 over the root of 2I, and then let me just write it properly. So we're going to find 1 over the root of 2I, then minus 1 over the root of 2j. So this is the unit vector in the direction of u. So now we've been told to say, after finding this, we now find the magnitude of this unit vector. So in other words, the magnitude of this is simply just the magnitude of that. So to find the magnitude of this, we say the magnitude of this. To find the magnitude of the unit vector of u, we simply just say, okay, let me do this so that at least you see what I'm talking about. So the magnitude of this is simply just the square root of that 1 over the root of 2. You square this, and then plus 1 over the root of 2. You square this, and then when you simplify this, you can agree with me to say you are going to have the square root of 1 over 2 plus 1 over 2, which will simply just give you 2 over 2, which will give you the square root of 1. Then the square root of 1 will simply just give you 1. So the magnitude of any unit vector is always 1. Okay. So in a similar way you solve this. Remember we at one point found this. So after finding this, first you add u plus v, you put it on top there, and then divide by the magnitude of u plus v, and then you find the magnitude of your result. So that's how you solve those questions. Same applies to this. Don't be scared when you see them in 3 dimension. You simply do the same things that you have done on the first question here, plus the same things that you are supposed to do even on these other questions. So I've solved all these questions in a PDF form. I'm going to send it to you if you request for it. Let's move on to the next question. So let's look at equivectors. So equivectors are simply said, two vectors are said to be equal if and only if they have the same magnitude and the same direction. So if the magnitude of a vector is the magnitude of one vector and the direction of that same vector is equal to the other vector, so you say that those two vectors are equal. So let's look at this example here. We have v this side. So they are telling us to say find the value of x and y such that v is equal to that. So now our v, so if you take your v to be this one, we are going to have 2, 1 as your v. This is equal to, you multiply x times u, and then your u has been given to be this. So when you multiply x times u, you are going to have x times u, meaning you are multiplying everything in u with x. So you are going to have x, okay, let me just write it this way, 1, 2. So sometimes when you're working with this, it's important for you to express them in the IJK notation. It really helps. Then you say what, and then plus y, then you open the brackets, 1, -1. Okay, so now here it's just a matter of simplifying this. So you are going to have x, 2x, and then plus y, -y, like that. So having done this, you can now also pair the like terms, or you put the like terms together. So that's why I was saying sometimes it's important for you to express this in the IJ notation. So you put the i's together and the j's together. So the I'll say here my I is 2, then this is equal to, this side I have my I to be x there, and then plus, I'll write my plus there, and then I have my I in this other one to be y. So x plus y is equal to 2, and then same applies on this other part. So this is my equation 1. I can also, so this is my equation 1. I can also take my j to be 1 there. Then in the other one my j is 2x. Then that other one my j is -1. So also negative y. So my j is -y there. So here what we can do is simply, if you want you can use elimination method, if you want you can use substitution method to solve the two simultaneous equations. So you solve the two simultaneous equations in order to get your value of x and y. So when you solve these two simultaneous equations, you make x the subject in this first equation. So when you make x the subject, you are going to have 2 minus y as your substitute value. Then you replace it in this one, and then once you replace it there, you are going to find your value of x and y to be equal to 1. So your value of x will be 1, and the value of y will also be 1, such that when you replace them there, you get 2. When you replace them there, you get 1 that side. Yeah, so these are the values of x and y you should find after solving these two simultaneous equations. So these two vectors are said to be equal because of this equal sign there in between. Alright, so this one can also be solved in terms of I, j and k, which should also give you the same answer. So let's quickly move on to the next question. So the question here says, find the unit vector that has the same magnitude, b that has the opposite direction, the same direction, and b that has the opposite direction as a given vector. So in this case, I'll take that. I can get any of these, but let me be taking at least any. Yeah, so any, more especially the simple one, so that I can at least cover a lot in this slide. Yeah, but I'm going to send the solutions for all these questions. Okay. So this one, to find the unit vector in the direction of this u. So unit vector of u is given by u cap, is represented by u cap, which is just equal to u divided by the magnitude of u. So u divided by the magnitude of u gives you the unit vector of u, or in the same direction as u. And then when you add the negative in front, then it gives you the unit vector in the opposite direction of u. So let's find the magnitude of u. So the magnitude of u is simply just equal to the square root of -3 squared plus 7 squared. Okay. Alright, so this one, what you can do again with this one is that you simplify it. You're going to get, so we have, this is 9 plus 49. So 9 plus 49 will give you 58. So the square root of 58, yeah, so the square root of 58 is the magnitude of u. So now to find u cap, we say we get that same vector, we divide it by the square root of 58. Even the other term there, 7 divided by the square root of 58. The square root of 58. And then this is our j. So this is the unit vector in the direction of u. So to find the unit vector in the direction of in the opposite direction of u, so for the unit vector in the opposite direction of u, this is just going to be, you multiply everything by negative, meaning you just remain with 3 over the root of 58, then I, minus 7 over the root of 58 j. Yeah, so this is how you simply solve all these other questions. Let's quickly move on to the next one. So here on this question, we're just being tested on the addition and subtraction of vectors. So z, they're saying find the vector z. The vector z is equal to u minus v. So the vector z will now just be equal to, we replace there. So our u is 1, 2, 3. This is our u. Then minus our v is 2, 2, negative 1. 2, 2, negative 1. So our z will simply just be equal to 1 minus 2, give us negative 1, comma 2 minus 2 give us 0, 3 minus negative 1 will give us 4. So this is our vector z. So you do the same even on these other ones. Just replace where there's u with what you've been given there, where there's V you put there, and then where there's W you also put that, then you simplify. Okay, let's quickly move on. So this other question says the vectors u, v and its terminal points are given, find the initial point. So for these two vectors, they're saying we've been given the vector itself and its terminal point. Now we have to find the initial point. Remember what I said? I said vectors are always found by head minus tail, or rather the terminal minus initial. So I'll denote my terminal to be t. So t minus initial, which is I, is equal to my vector v, I mean vector u in this case. So have I been given the terminal? Yes, it's there, which is just 0, 6, 2, 0, 6, 2. So this is just a point. Then minus the initial has not yet been given. This is what we've been asked to find. Then u has been given. So u has been given, which is 3, -5, and 6. So to find the initial, which is just I, I'm denoting the initial as I. So I is just going to be equal to this, which is 6, 0, 6, 2, say minus 3, -5, 6. So when you subtract the 2, we get the value, or rather we get the vector, or we get the point of the initial. So 0 minus 3, you get -3. 6 minus 5, you get 11. 2 minus 6 minus -5, you get 11. And then 2 minus 6, you get -4. So this is the initial point. Let's quickly move on. So you solve this question in the similar way I've solved this one. So let's quickly move on. So this other question says determine which of the vectors is parallel to z. So for two vectors to be said to be parallel, so if two vectors are parallel, if vector A is parallel to vector B, it means that A is equal to K times B. So if A is parallel to B, it means that A is equal to K times B. So this K is just a scalar multiple of B. So in other words, two parallel vectors look like this. When you have a vector which is moving in that direction, there's also another vector which is moving in that direction. So when two vectors are parallel, the only difference between the two vectors is that one will be shorter than the other. So meaning one will be a multiple of the other vector. So if Z is parallel to either U, V, or W, it means that U, V, or W are scalar multiples of Z. So let's try to look at one of these questions that we've been given. So you look at this question. When you look at this one, Z is equal to that. So Z is 3, 2, -5. So is there a way that we can make U, or is there any number that we can multiply with U in order to get Z? If there is no number that can work in that format, then the Z is not parallel to U, because Z is not equal to KU. So Z is not parallel to U because Z is not equal to KU. So let's check V. Is there a way that we can, or is there a number that we can multiply with V to get Z? Or is there a number that we can factorize from v to get z? Yes. So v, so z, so v can also be written as negative 2 open brackets, let me use this, so negative 2, and then open brackets we have 3 comma 2 comma 5 comma negative 5. So when you look at what is in the brackets here, this is just the same as z there. So in other words, v is just equal to k times z. So v is just equal to k times z. Hence, v is parallel to z. So that is how you deal with parallel vectors. And then we can also try to check w. We check w whether w is parallel to z as well. So when you look at w there, is there anything that we can do to w to make it be a multiple of z? So let's try to check. So w can also be written as we can also write w as 3 over 2 times sorry, not 3 over 2 but 2 over 3. We can write this as 2 over 3 times 3 and then comma. Okay, so I think what I wrote was just okay. Supposed to be 3 over 2, not 2 over 3. 3 over, so it's supposed to be 3 over 2, and then there we write wait, okay, so we have something like this. Yeah, so I was just factorizing it on the separate paper here. So when you factorize this by 2 over 3, this is what you get, such that when you multiply through this, you go back to that. So this w can also be written now as k times z. So k times z, which one is our z? So this v, I just forgot to write this. So this v can also be written as negative 2 times z. So this one can also be written as our k will be 2 over 3 times z. So this is what you're going to have as your so in short, w is parallel to z because w is 2 over 3z, and the scalar multiple that we have there is 2 over 3. So let's quickly move on to the next question. You solve the other question in a similar manner. Okay, so this one says determine the values of c that satisfies the equation u is equal to that, and then v is equal to that. So in other words, they are saying when you multiply c times u and then you find the magnitude, it should give you 25 as your solution. So we're going to say cu, so cu is just the same as c negative I plus 2j, so negative I plus 2j, and then plus 3k. Right, excuse me for that. So plus 3k. Then when you find the magnitude of this, you're supposed to get your answer to be 25. So the magnitude of this is simply just the square root of c squared, and then you have negative 1 squared, then plus 2 squared, then plus 3 squared. So this is equal to 25. So when you square root this, we're going to have c squared there. Then this will be 1 plus 4, which is 5 plus 9, which is 14. So we have 14 there. And then apart from that, you can now have this one is equal to 25. Then from there, the square root of c squared is just c. So we are going to have something like this: c square root of 14 is equal to 25. So the value of c there will now just be equal to 25 over the root of 14. So this is what you are going to have. You do the same way. You solve question 2 in a similar manner. Okay, so let's quickly move on to the next question. So let's look at the dot product of two vectors. So what does it mean when you talk about the dot product of two vectors? So if your vector, you have a and b like that, the dot product of two vectors is simply just a multiplication of two vectors. So when you multiply this vector and that vector, putting in mind that I times I is equal to 1, and then j times j dot j is equal to 1, then k dot k also being equal to 1. You also note that the other way around is giving you zeros. When you say j times k, sorry, not times but dot k, so j dot k, this will give you a 0, j dot I will give you a 0 as well, I dot j, I dot k will give you a 0 as well. So when you put in mind these, when you put this into consideration and then multiply these two vectors, we discover that what the solution that you are going to find is simply just a times b1, meaning a1 times b1, a2 times b2, a3 times b3. Or the other way you can find the dot product of two things given the angle is, two vectors given the angle between the vectors. If you have the angle theta between the vector a and the vector b, you just find the magnitude of vector a and the magnitude of vector b, and then you say cos that given angle. So when the dot product of two vectors is equal to 0, it simply means that the angle between them is 90 degrees. Why do we say so? Because we know to say cos 90 is simply just 0. Okay, let's quickly solve at least one or two questions, then we see what follows. So this now takes us to question 9. If they tell you to find u dot v, remember what we said. So u dot v would simply just be found by multiplying these two vectors. So you just simply multiply the corresponding terms. 3 times negative 1, you get negative 3, and then you say plus 4 times 5, that is a 20. So u dot v here is just giving us 17. Same applies to u dot u. You simply just dot the same u. Say 3 times 3, so you say u dot u is simply just equal to, you multiply 3 times 3 there, you get 9, then plus 4 times 4 is 16. So 4 times 4 you get 16. So u dot u just give us 25. Okay, so this is how simple these things are. And then this one just simply means you find the magnitude of u. After finding the magnitude of u, and then you square it. So the magnitude of u, if I'm taking this as my u, the magnitude of u will simply just be the square root of 3 squared plus 4 squared. So 3 squared plus 4 squared, this is just the same as 9. 9 plus 16 gives you 25. So the square root of 25. So the square root of 25 is simply just 5. Then when we say the magnitude of u squared is just the same as 5 squared. So the magnitude of u squared, this will give you 25. So this is how you do. So here you already have your u dot v, which is 17. You just need to multiply it with v, that's all. So u dot v times v is just the same as 17 times this vector v there, which is negative 1, 5. So the brackets are supposed to be like that. So which gives you negative 17, then you multiply 5 times 17 there, you get something like 85. So this is how you do with dot products. So let's quickly move on to the next question. You also solve this other questions in a similar manner. Yeah, there's no difference. That's why I'm solving just one questions, because they're just the same. So vectors are simple. So this other question says, find u dot v given that the magnitude of u is 8, the magnitude of v is 5, and the angle between u and v is pi over 3. So this pi over 3 is just the same as 60 degrees. When you say 180 divided by 3, you get 60 degrees when you convert it. So to find u dot v using those given values is simple, because we know to say u dot v can also be found by saying magnitude of u times the magnitude of v, and then we say cos the angle between the two vectors. So u dot v will now be found by saying what is the magnitude of u. The magnitude of u is 8, then the magnitude of v is 5, then cos 60 degrees. So u dot v is just simply, so this will be 40 times, and then cos 60 is simply 0.5. So cos 60 is simply 0.5, which is just half. So our u dot v, will simply just be 20. So you solve the other question in the same way. Yeah, so even this other question, which is this one, you solve it in the same way. You've been given the magnitude of u, the magnitude of v, and the angle between the two vectors. Okay, so let's quickly move on to the next question. I think this is going to be our last question for today, and then the other questions I think I'll put them in the next lecture video that I'm going to make. Questions like question 12 going up. So for today we're just going to end at question 11. So let's solve this question, saying find the angle between the vectors, this one and that one. So these two vectors, we know to say u dot v is given by the magnitude of u times the magnitude of v. So the magnitude of u times the magnitude of v, and then cos the angle between the two vectors. So the magnitude of u times the magnitude of v cos the angle between the two vectors. So to find the angle, we just make cos theta the subject. So we say cos theta will just be equal to u dot v over the magnitude of u times the magnitude of v. Then we're going to have our u dot v to be equal to that. Then we're going to say cos theta is equal to, then u dot v is just going to be equal to 1 times 2 there, you get 2, and then 1 times negative 2, you get negative 2. So you're going to have that as your u dot v, and then the denominator there will be the square root of 1 squared plus 1 squared, you get the square root of 2 times the square root of 2 squared, which is 4, plus negative 2 squared, another 4, so meaning the square root of 8. So the square root of 8 is 2 root 2 times root 2, you get 4. So this one is just the same as 0 over 4, which gives you 0. Then we know to say cos theta is equal to 0. Then theta is equal to the cos inverse of 0. So cos inverse of 0 is simply 90. So it's just 90 degrees. So the angle between the two vectors is 90 degrees. This vector and this other vector. So same applies to these other questions. You solve them the same way. Let's try to solve one more question. Since this is the last question, so we can solve maybe 2 or 3 questions from there. So let's look at this one. So this one we also solve it in the same way. We know to say cos theta is just equal to u dot v over the magnitude of u dot times the magnitude of v. So cos theta is equal to u dot v. So u dot v is equal to this. So u dot v is just found by multiplying this. So 3 times 2, we get 6. Then we say plus 1 times negative 1, you get negative 1. So we can just say minus 1. Then over the magnitude of this is just 3 squared plus 1, which is just 9 plus 1, which is 10. So we have the square root of 10 there, multiplied by the magnitude of v is 2 squared 4 plus 1 squared, which is the square root of 5. So this will simply just give us 5 over when you multiply the 2, you get the root of 50. So the root of 50 can also be written as so it's a 5 over, so you can also write it as 2 times 25 there. So you can say 5 root 2. So this is just the same as 5 root 2. So you can see that that 5 and that 5 can cancel. And then of course this side was still with cos theta. So we have just remained with 1 over the root of 2. So to find theta, we can just say cos inverse of 1 over the root 2. So cos inverse of 1 over root 2 is just 45. So this one will give you 45 degrees. So the angle between these two vectors is simply just 45. Okay, so you solve the other vectors in the same way. Yeah, you solve them in the same way. Yeah, so thank you very much for watching today's video, today's lesson. So if you have not yet subscribed to the channel, you can subscribe so that the videos that I'll be posting you don't miss out. Okay, so see you in the next lecture video, where I'm going to continue from question 12 up to the last question in your tutorial sheet. Then apart from that, I'll also explain some more concepts that like the direction, cosine, angles, and I'll also explain some other concepts which are very important on vectors, like finding the area given given two vectors, or finding the cross product of two vectors. Alright, so don't miss the next lesson. See you in the next lesson. Shalom, shalom.